everybody, welcome to Science Side Up. I'm Maddie, and today we're going to talk about how weather radars work. This is a MASH reference for anyone under 45. Okay guys, so I have spent the last 2 weeks out on a field campaign chasing storms around the Great Plains. It was part of TORUS, which is it was a joint research project with NOAA, the National Oceanographic and Atmospheric Administration, and NSSL, which is the National Severe Storms Laboratory, and then the University of Oklahoma and the University of Colorado and Nebraska and Texas Tech. So we have been out driving all over the plains, chasing supercells, and it was a really great experience. I had a blast. I saw some really cool storms, and there's going to be a video just on that coming up very soon. I'm working on editing and final touches, so look for that. But between now and then, I thought you might like to know how weather radars work, because that was one of the main instruments that we had out in this campaign. So we would drive our radar truck out to where we thought a storm was going to be and start sampling and all that jazz. So radars were invented right around World War II, and the intent was to be able to find planes. That's a nice thing to be able to do. We would like to know where planes are sometimes. And weather radars, they work pretty much the same way as radars that find airplanes. So let's talk about the ones that find airplanes first, because they're a little easier to understand. So this is my radar dish, and this blobby purple thing is totally an airplane. And the way this works is that my radar dish, it's gonna send out a signal, like a radio signal. So it goes like this, pew, pew, pew. It doesn't actually make that noise, but I think it's better with sound effects. And the signal that it sends out hits the plane, right? It's not going to do any damage. This is like a radio signal. But once that signal hits the plane, it bounces off of it and comes back to the radar dish. Pew, pew. And so if you think about how like a bat sonar works, they send out a sound wave and it hits the bugs, and then those waves bounce off the bugs and come back to the bat, and it tells the bat where it is. That's exactly how this works. It's just using radio waves instead of sound waves. So we know where the radar dish is, and we know how long it took for the signal to come back, right? So if you like kind of cut that time in half, then that'll tell you how far away the plane is. And in a nutshell, that's how radars work. It sends out a signal, it hits stuff, the signal comes back, and based on how long it takes for the signal to come back is how far away the object is. So if we send out another signal, right, this one will be white just so we can see the difference. Pew, pew, bam, hits the plane and then comes back. If the plane has moved, then it's going to be a shorter distance, right? And so we're sending out these signals really rapidly. So not only can we figure out where the plane is, we can also figure out how fast it's moving. So we can know position and velocity. Fundamentally, weather radars work exactly the same way as this radar that found the plane. The main difference is in the wavelength of the signal that the radar dish sends out. If you've had a chance to watch my video on gamma radiation, I'll put a link below in the description, then you know that radio waves are just one type of electromagnetic wave. It turns out with radars, the size of the object that they're best at finding is related to the wavelength of the signal it sends out. Really grossly speaking, the bigger the object, the bigger the wavelength. So if we're going to use a radar to look at the weather, we need to think about what we're actually trying to find and then design our radars to find that object, right? Figure out what the best wavelength is going to be. So weather radars actually look for water. So they're looking for water droplets in the atmosphere. Lots of water droplets is going to mean big clouds, lots of potential for precipitation. So weather radars are going to send and receive signals in the microwave range. And the bigger and more dense and more water that's in the cloud, the stronger the signal the radar is going to receive. And just like with a plane, we can look at sort of what's there and the velocity. So we can know how fast any water in the air is moving, right? And then we can know kind of how big these cloud systems are. So the bigger the signal, right, a really big signal, that's going to mean like a storm potentially. And then we can use the velocity to figure out storm motion, or is there any type of circulation going on? And that can be really important for figuring out what kind of storm this is, right? Are we just going to get a nice little rain shower, or are we like looking for a tornado? So that's Weather Radar 101. And now that we kind of know how this works, let's go take a look at some actual data. This is radar.weather.gov. You can go there anytime you like and look at any of the output from our national network of radars. So we're going to check out Florida. It's a summer afternoon in Florida. So yeah, we get some showers. So what we're looking at here is reflectivity, which is just kind of how much water is in the air. And as we might expect in a summer afternoon in Florida, lots. So if you see that bit of red there, that's going to be lots. The units here are kind of strange. It's called dBz. But anywhere you see a signal, those greens and yellows and reds, what you can expect is that there are clouds in the sky, and that those clouds are, if not actively raining, then capable of producing rain. So now let's go over and we're going to look at velocity, because that was something else that we could look at. And so you notice here, so we have two different colors, right? We've got red and green. So reds are positive values and greens are negative. So reds mean that the water vapor, that the water is going away from the radar, and greens mean that it's coming towards it. So that's the very basics of how to read some weather radar data. And I will talk more about that in my video about the field campaign. But this should give you a good baseline level of knowledge to understand some of the more complicated type stuff we look at in that video. So for now, please like and subscribe. Let me know what you thought down in the comments. If there's a topic you would like to see me cover in the future, you can reach me at ScienceSideUp@gmail.com. And then until next time, I'll see you guys later.